The height of a right circular cylinder is 5. So let me draw a right circular cylinder here. So essentially it would look like a can. So that's the top of it, and that's the sides of our cylinder. So it would look something like this, and then this is, if it was transparent, you could see this side right over here. So that's our right circular cylinder, and they say that the height of it is 5. So this distance right over here is equal to 5. So that's the height of my right circular cylinder. And the diameter of its base is 4. So the diameter of its base, so this distance right over here, is equal to 4. What is the distance from the center of one base, so we could take either the center of the bottom or the top. I'll do the center of the top. So the distance from the center of one base, so that could be that point right over there, to a point on the circumference of the other base. So this would be the other base, and a point on the circumference, well, that could be a point on the circumference right over here, or that could be a point, or that could be a point, or that could be a point. But I'll pick this, actually, I'll pick this point right over here, because it'll make our visualizations a little bit easier. So what we could do, so we need to figure out this distance right over here. And it might jump out at you that we could construct a right triangle where we know two of the dimensions. And if we know two of the dimensions of a right triangle, then we can use the Pythagorean theorem to figure out the third. So we already know that this height right over here, this is the height of our right circular cylinder, or the height of our can. We already know that this distance right over here is 5. And this is the distance from center to center. Now, what is the length of the radius? Well, the diameter is 4. So the radius right over here, I'll do the radius in a different color. The radius right over here, this distance right over here, is going to be equal to 2. So the distance in question, which we could call, I don't know, let's call it x, that's what we need to figure out. That's the hypotenuse of this, that's the length of the hypotenuse of this right triangle. So we know from the Pythagorean theorem that the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. So we know that 2 squared plus 5 squared is going to be equal to the length of the hypotenuse squared. It is going to be equal to x squared. Or we could say that 4 plus 25 is equal to x squared. Or we could say that, I could write it this way, 4 plus 25, well, that's just 29, is equal to x squared. We could take the principal root of both sides. We only care about the positive square root because we're talking about a distance here. Negative really wouldn't make sense. And so we could say that the principal root of 29 is equal to x. So x is equal to the square root of 29. And if you want to make sense of that, let's see, 5 squared is 25, 6 squared is 36. So this is going to be in between 5 and 6 units long. But it's the square root of 29 is the length of this distance that they ask us about.